Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache Pinot, a powerful real-time analytics platform designed for low-latency queries on massive datasets. Whether you're building real-time dashboards or powering customer-facing analytics, Pinot delivers sub-second responses. It's especially optimized for append-only, time series, or event-based data, making it ideal for monitoring systems, clickstream analytics, and more. Pinot stands out in the analytics landscape because of its ability to handle real-time ingestion while maintaining sub-second query performance. It supports hybrid tables that combine batch and streaming data, making it versatile. With SQL compatibility and support for pluggable storage systems like S3 and HDFS, it's both flexible and powerful. Pinot's architecture is composed of several specialized components. The controller manages cluster state and metadata. Brokers route queries and merge results. Servers host data segments and execute queries. Minions perform background tasks like retention. Data is stored in immutable columnar segments for performance. The controller is the brain of a Pinot cluster. It maintains all metadata, including schemas and table configurations. It uses Zookeeper for cluster coordination and provides REST APIs for managing tables and ingestion jobs. It also handles segment assignment and ensures data distribution across servers. Brokers act as the query gateway. They receive SQL queries, parse them, and route them to the appropriate servers based on segment metadata. Once results come back, brokers merge them and return a unified response. They also perform optimizations like pruning irrelevant segments. Servers are where the data lives and queries are executed. Each server hosts multiple segments and processes queries locally. They support both real-time ingestion from streams like Kafka and offline batch ingestion. Segments are compressed and cached for performance, and servers manage their lifecycle from creation to cleanup. Minions are optional but valuable for long-term maintenance. They perform tasks like segment compaction to reduce storage overhead, enforce data retention policies, and clean up obsolete data. These tasks can be scheduled or triggered manually, helping maintain optimal cluster performance. Data in Pinot is stored in segments, immutable columnar units optimized for analytics. Each segment typically ranges from 100 MB to 1 GB. They're partitioned by time or other keys, compressed for storage efficiency, and loaded into memory for rapid querying. Segments can be stored in various backends like HDFS or S3. One of Pinot's standout features is hybrid tables, which allow you to query both real-time and offline data as a single logical table. This is ideal for pipelines where data comes from streams like Kafka and batch systems like Hadoop. Queries seamlessly span both sources, ensuring data freshness and completeness. Pinot supports a rich subset of ANSI SQL, enabling complex aggregations, filtering, and grouping. You can query via JDBC drivers or REST APIs. Query optimization includes segment pruning and column projection to reduce latency. Schema Evolution is supported without downtime, allowing flexible data modeling. Pinot supports flexible ingestion pipelines for both real-time and batch data. Real-time ingestion typically comes from Kafka, while batch ingestion can be done via Spark or Hadoop. The ingestion framework is pluggable, allowing custom transformations and validations. Once ingested, data is automatically converted into segments. Pinot is optimized for time series data, making it ideal for monitoring, observability, and analytics platforms. It uses time-based partitioning to align segments with temporal windows. This enables efficient pruning of irrelevant data during queries, reducing latency and improving performance. Pinot is engineered for performance. Most queries return in under 100 milliseconds. It can handle thousands of queries per second per node and scales to petabytes of data. Segment sizing is optimized for memory and disk I/O, and the system scales horizontally by adding more nodes. Pinot is flexible in deployment. It can run on-premises or in the cloud, supports Docker and Kubernetes for orchestration, and integrates with pluggable storage systems. You can monitor it using Prometheus and Grafana and deploy it across multi-cloud or hybrid environments. Pinot powers real-world analytics solutions across industries. From tracking user behavior in real time to powering customer-facing dashboards and monitoring infrastructure performance, it's used for high-impact, low-latency analytics. Let's visualize how all these components work together. The controller manages metadata via Zookeeper. Brokers route queries to servers which host the data. Ingestion pipelines feed data into the system, and hybrid tables unify real-time and batch views. When a query is issued, it's sent to a broker, which parses it and routes it to the appropriate servers. Each server executes the query on its local segments. The results are then merged by the broker and returned to the client. This entire process is optimized for speed and efficiency. Segments are the core storage unit in Pinot. When data is ingested, it's converted into immutable segments. These are loaded into memory for fast access. Over time, segments may be compacted or cleaned up by Minions. They're stored in pluggable backends like S3 or HDFS. Performance benchmarks show that Pinot delivers sub-100 ms latency for 95% of queries, supports over 1,000 queries per second per node, and scales to hundreds of nodes. Segment sizing and query pruning are key to maintaining performance at scale. Compared to alternatives like Druid, Elasticsearch, or ClickHouse, Pinot stands out for its SQL compatibility, real-time focus, and low-latency querying. While Kafka Streams is great for stream processing, Pinot adds persistent, queryable storage. Pinot supports Schema Evolution without downtime. You can add new columns or change data types, and the system will automatically handle migration of existing segments. This makes it adaptable to evolving data models. Pinot supports multi-tenancy, allowing multiple tables with different configurations to coexist in the same cluster. This is perfect for SaaS platforms where each tenant may have unique requirements while sharing the same infrastructure. Pinot integrates with monitoring tools like Prometheus and Grafana to provide real-time observability. You can track query performance, segment health, and ingestion rates, and set up alerts for anomalies or performance issues. Security in Pinot includes authentication via LDAP or JWT, role-based authorization, TLS encryption for data in transit, and audit logging for compliance. It integrates well with enterprise identity management systems. Getting started with Pinot is easy. You can run it locally using Docker in standalone or cluster mode. Sample datasets are included for testing, and REST APIs make ingestion and querying straightforward. Kubernetes Helm charts are also available for production deployments. Deploying Pinot on Kubernetes is streamlined with Helm charts. You can enable auto-scaling, use persistent volumes for storage, and benefit from DNS-based service discovery. Rolling updates and rollbacks ensure smooth operations. To get the most out of Pinot, optimize segment sizes, use time-based partitioning, enable query pruning, monitor segment health, and leverage hybrid tables for mixed ingestion pipelines. These practices ensure performance and scalability. When troubleshooting Pinot, start by checking segment loading status and reviewing query execution plans. Monitor ingestion lag, validate schema compatibility, and use logs and metrics to gain insights into performance bottlenecks. In e-commerce, Pinot enables real-time tracking of user behavior, clickstream analysis, and insights for personalization. It helps monitor conversion funnels and analyze A/B testing results with millisecond latency. For IoT, Pinot handles real-time ingestion of sensor data, enables anomaly detection, and powers predictive maintenance dashboards. It scales to millions of devices and supports edge-to-cloud analytics workflows. In infrastructure monitoring, Pinot powers live dashboards, alerts on anomalies, tracks resource utilization, and monitors service health. It integrates seamlessly with Prometheus for unified observability. Pinot has a vibrant open-source community. You can find support on GitHub, Slack, and mailing lists. The documentation is extensive, and there are tutorials, conferences, and meetups to help you get involved. To master Pinot, start with a local Docker setup, learn SQL querying, understand ingestion pipelines, explore hybrid tables, and dive into performance tuning. Each step builds on the last to give you full proficiency. To recap, Pinot's strengths include low latency queries, real-time support, and SQL compatibility. However, it's not suited for transactional workloads, and segment sizing is crucial for performance. It's scalable and flexible when configured correctly. Pinot integrates with Kafka for ingestion and can be compared with Druid, ClickHouse, Elasticsearch, and Presto. Each has its strengths, but Pinot excels in real-time, low-latency analytics scenarios. In summary, Apache Pinot is a powerful platform for real-time analytics with low-latency querying. Its hybrid tables, scalability, SQL support, and flexible ingestion make it ideal for monitoring, event analytics, and customer-facing dashboards. If you found this deep dive into Apache Pinot helpful, give it a like, subscribe for more tutorials, and drop your questions in the comments. Share this with your data team and check out the related videos below. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.